Here's example 10 with the chain rule. So we have z equals 4w plus 1 quantity raised to the negative third, and then multiplied by e to the inverse sine of w. So we want to find dz dw. In other words, this is the derivative of z with respect to w. Now, there are a couple different ways to do this. We could leave z like this and then do product rule. And then, of course, with the product rule, we'll have to do the chain rule. Or we could rewrite this a different way and do the quotient rule. And actually, let's go ahead and do it like that. Because, if we leave it like this, then we have to deal with negative exponents, which I guess isn't really too bad, but it's nice to avoid them if we can. And in this case, we can. So we could rewrite this as e to the inverse sine of w, or we could say arc sine, right? We could say arc sine instead. But here, 4w plus 1 to the negative third, that's the same thing as divided by 4w plus 1 to the positive 3. Okay? So here's our function z rewritten like this, and we'll do the quotient rule on this. So actually doing the quotient rule really won't be that much more complicated than it would have been to do the product rule here. So let's go ahead and continue with this then. So if we want to find dz dw, then we're just going to do the quotient rule on this. So quotient rule says, okay, the derivative, let's move this down a little bit. Okay, so dz dw equals bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so we're going to need a lot of room here. Bottom is 4w plus 1 cubed. Alright, that's our bottom. Now we multiply by the derivative of the top. So what's the top? It's e to the inverse sine of w. Remember, so we're taking the derivative of this. So remember, derivative of e to a thing is just e to that thing times the derivative of that thing. And that thing in this case is inverse sine of w, so the derivative is 1 over the square root of 1 minus w squared. Alright, so everything is kind of squished into here, so let's maybe give ourselves some more room to work with here. Times, a little better, 1 over the square root of 1 minus w squared. Alright, so that's from the chain rule. Remember, the chain rule says derivative of e to a thing is just e to that thing times the derivative of that thing. So that's where this 1 over root 1 minus w squared comes from. Okay, so that's bottom times derivative of the top. Now we do minus the top times the derivative of the bottom. So this is minus the top. Now we multiply by the derivative of the bottom. Okay, now the bottom is what? Is 4w plus 1 quantity cubed. So the derivative is going to be 3 times 4w plus 1 squared. Okay, that's a derivative of the big guy. Okay, the big guy is cubing things. So the derivative of the big guy evaluated at the little guy and then multiplied by the derivative of the little guy. Okay, so in this case, on the bottom, the little guy is 4w plus 1, the big guy is cubing things. Okay, the derivative of w cubed is 3w squared, but the chain rule says evaluate the derivative of the big guy at the little guy. Okay, so derivative of the big guy, evaluate at the little guy, so we have 3 times the little guy squared, and then multiply by the derivative of the little guy. And the little guy is 4w plus 1, so the derivative of that, derivative of the little guy is just 4. Alright, so just to recap real quick, bottom times the derivative of the top, okay, times the derivative of the top, minus the top times the derivative of the bottom, all divided by the bottom squared. So the bottom is 4w plus 1 cubed, and if you take something cubed and square it, then your power becomes 6. Okay, so the bottom is 4w plus 1 cubed times 4w plus 1 cubed, so that's going to be 4w plus 1 to the 6th. Okay, so let's zoom out a little bit just so we can see everything here. So that's our derivative so far. Okay, it's kind of messy, right? We got a complex fraction there. But it's actually not really too bad, I guess. Let's go ahead and... how should we simplify this next? Let's go ahead and do this. Let's say... Well, first of all, there are some common factors we can pull out. So notice here's a 4w plus 1 cubed, and here's an e to the inverse sine of w. And then in the second term, here's another e to the inverse sine of w, and then here's a 4w plus 1 squared. All right. So actually, from the whole top, okay, let's go ahead and extend that there. So from the whole top, we can pull out an e to the inverse sine of w. All right, and that's good. But we can also pull out a 4w plus 1 squared. Okay, so we'll pull out a 4w plus 1 squared. All right, and now what's left here? Well, if we pulled out a 4w plus 1 squared, then here's 4w plus 1 cubed, so we're still going to have a 4w plus 1 left. Okay, 4w plus 1 left. And then multiplied by, this is still here, 1 over root 1 minus w squared. Okay, that's still there. And then we still have minus what? E to the inverse sine of w, we pulled it out. 4w plus 1 squared, we already pulled it out. But here's a 3 times a 4 still there, so we have minus 3 times 4 is minus 12. Alright, now all of that's being divided by 4w plus 1 to the 6th. Okay, so let's zoom in a little bit here. Now this is good because we can cancel some stuff now, like it's just one thing. 4w plus 1 squared cancels with 4w plus 1 to the 6 on the bottom, and the power down here becomes a 4. Okay, so that's good. Now we can write this like this. So that's actually pretty much it for simplifying, but now we can just clean this up a little bit. Let's say e to the inverse sine of w divided by 4w plus 1 to the 4th, okay? And then times this 4w plus 1, and then divided by root 1 minus w squared. And then we still have minus that 12. Okay, so that's just all the same stuff, but cleaned up a little bit. So that's our derivative here, this guy right here. Okay, and if we did the product rule up here instead of the quotient rule, we would end up with the same answer. It might be in a slightly different form, but either way it could be rewritten to be like this. So this isn't really too bad, right? You know, algebraically simplifying it, kind of a mess, kind of, sort of, because there's a lot going on here. You know, we had to do the quotient rule, and then we had to do the chain rule for the top and the bottom, you know, separately. But it wasn't really too bad. But anyway, this is example 10 with the chain rule here.